So good morning everyone in the online class, offline class.
Good morning, sir.
Let us start today's class. This is I think lecture number 5 on circular dynamics.
Sir,
And yes, beta.
sir, can you hear the voice, sir?
Yes, I can hear your voice.
Okay, sir.
Okay. So what we have discussed so far, this is lecture number 5 on circular dynamics. In the last class, if I go back, we had discussed centripetal force, tangential force, and how to find out the force, how to equate those forces. First, we have to find out the net force in one direction. If it is in the If it is the total net force, F net will be equal to mass multiplied by acceleration, that is Newton's second law. You can find out the total net force and equate it to mass into acceleration. That is Newton's second law. We are only going to apply Newton's second law in this case also, but here we might be applying we might be using these forces or applying this equation in two directions. One direction is your tangential direction. So what I'll do is we will find out the net force in the tangential direction and equate it to m into at, where at happens to be your tangential acceleration. And then we might be required, definitely we will be required, because this is a chapter on circular motion. Particle is going to move on a circular path. Whatever happens, it is going to have centripetal acceleration because it is going to change its direction. So we have to find the net centripetal, we have to find the net force towards the center. That will be the centripetal force, net centripetal force, and that should be equal to mass into centripetal acceleration. We had also seen some examples where we had written the equation for centripetal force, namely in the case of moon moving around earth, case number 1, the only force acting between moon and earth, or the force acting on moon, which is moving it around the circular orbit, is the gravitational force G, m, capital M, mass of earth, small m, mass of moon, divided by r square. R is the distance between the center of the earth and center of the moon. Gravitation is going on in the other class, so you must be knowing it. That must be equal to the centripetal force m, small m, mass of the moon, into Vt square by r. So this is how planets move around the earth. Moon moves around the earth. The only question is what set this planet into motion, and that is the question that physicists right now are working on. Centripetal force makes them move, yes, but what started the motion? We are still looking for those things that have started the motion. That is the next frontier in physics, astrophysics you call it, or general physics you call it. Then we also saw the example of a stone attached to a string and moving in a vertical circle. And what did we find out? That there is tension upwards. At the lowest point, tension is upwards, mg is downwards. Net force towards the center, towards the origin, towards the center of the circle is T minus mg, and this T minus mg must be giving it the centripetal force, and that centripetal force will be m into AC. That will be equal to m into Vt square by L. I hope everyone understands up till this point. Can I have some raised hand that we understand up till here? Online class and offline class? You all understand up till this point? What about the online class? Teja, Shri, Satvika, Sai, Raju, Sainath, are you there in the class? Okay. That will take us to today's class. And before starting today's class, let us write the first heading. And the first heading is steps for solving problems in circular motion. So we will just write a series of steps, and those steps we would be following them judiciously, and with those steps we would be solving any problem that comes in this chapter. Okay, now what would be the first step? You are given a problem. You are given a problem on circular motion, and again I told you, any motion, any motion, whether it is on a zigzag path, is a part of a circular motion. It has a center and it has a radius. We call that radius as radius of curvature, and we'll find out a formula for radius of curvature as well. Don't worry, it will be coming. Right now, what is the first step that we must do? What is the first step to solve any problem on circular motion? Remember, the name of the chapter is circular dynamics. So we'll be solving problems on force. What should be the first step of solving the problem? It is circular dynamics. What will be the first step? And the first step always remains same. And it has remained same till eternity. I mean, since eternity, it is same. What is the first step of solving any problem in circular dynamics? What would be the first step? Anyone? No one knows? What would be the first step? We are dealing with forces here. What should be the first step? Online class, offline class? No idea? No one has any idea? That's very sad if no one knows. The first step is obviously to draw the free body diagram showing all the forces acting on the body. And this remains same. This is the basics of physics. Whenever you encounter a problem, you draw a diagram. If you don't draw a diagram and you are able to solve a physics problem without drawing a diagram, either you have done it correctly, either you have done it wrongly, or you are plain lucky. Because no problem in physics can be done without a diagram. If ever in your life, in your entire life, you can solve a physics problem without drawing the diagram, either you have done it absolutely wrongly, stupidly, or you are plain lucky. There's only two ways you can do it. Otherwise, you cannot solve a problem in physics without drawing a free body diagram. So we have to draw a free body diagram showing all forces acting on the body. What should be the next step? We have written these steps before also. I don't know how many of you remember it, because I don't know how hard are you studying. I still have my doubts. What is the next step? I have drawn the free body diagram and I have drawn all the forces. Then what should I do? What should be the next step? What should be the next step? Does anyone remember we had done similar thing in chapter known as, there was a chapter, I must take you back in time and let you know that there was a chapter known as Newton's laws of motion, which was done some 2-3 months back. Does anyone recollect that chapter, Newton's laws of motion? Anyone recollect that chapter, Newton's laws of motion, F is equal to ma something something? Has anyone got any memory of that chapter? Well done. No one has any memory. It's good not to have a good memory, but it is going to be fatal in your case, because if you forget it so soon, 2 months before we had that chapter, and if you have forgotten it, well, I must congratulate you and let you know that you are destined to be doomed in the exam that is going to come, because the exam is going to be same time in the next year, 2 months, 3 months after the 15 months you have. And if you can't recollect what we have done 2 months before, nothing in this universe is going to save you from being doomed. Yes.
Sir, isolate all the bodies.
Okay, isolate all the bodies. Beta, we have already drawn the free body diagram. That means you have isolated the bodies, right? You isolate the bodies, then only you draw a free body diagram.
Choosing convenient coordinate axis.
What would be those convenient coordinate axes? Well done. What should be those convenient coordinate axes?
X and
Remember,
Y, sir.
how will I choose X and Y? Remember, it is going to move on a circular path. How should I choose x and y? How should I choose x and y? That is the question. We don't solve circular motion in the same way as we have solved normal motion. In normal motion, we choose x and y. Sometimes x is horizontal and y is vertical. Sometimes it is, if it is on a plane, x-axis is like this and y-axis is like this. You can always keep them fixed. But this is circular motion. Body is going to move like this. How should I choose x and y? Because if I choose x and y, it becomes a very complicated motion to understand. How should I resolve the forces? That is the next question. See, the problem with you guys is you don't utilize your brain at all, and that is one thing that you must do. I mean, if you are in the medical field, you might not utilize your brain in physics, because you will not be encountering any problem where you have to use this. Is only this hard work and writing. But if you are aspiring to become an engineer and get into an IIT and IIT, if you don't do this, even if you clear the exam, you will not become an engineer at all. Use this. Use this. Use your brain. Once you use your brain, it will help you in cracking a question that we might not have done in the class, but it comes in the exam. What should be the convenient directions? What should be the convenient direction? And I'm giving you a hint. The hint is here. We have already done that. There is nothing that I have not told you, but I expect that you can relate. You can relate all these things together, and that is how you become smarter. Relate. What should be those convenient direction? Anyone in the online class? Offline students hardly know anything. Online one, anyone knows anything? And the challenge is open to all. What should be those convenient directions? The answer is right there on your screen. You have just need to utilize your brain. Just start to kick, just make a kickstart and tell me what will be those convenient directions. Where you have to resolve forces. No one in the online class also. So everyone is sleeping, I guess. No one in the offline class.
Sir, along tangent and radius.
Yes. That's it. That is why we have written tangential acceleration and centripetal acceleration, because those are the two directions in which we are supposed to resolve the forces. It is as simple as that. That is how you relate everything. You have to resolve forces along two directions. One tangential, the other radial or towards the center. That is how you solve any problem in circular dynamics. Am I clear with this point, everyone? Can I have some raise hand that we
Yes,
understand
sir.
this? Offline class, we understand this. What are the two directions in which we have to resolve forces? Everyone? Okay. Now, that is what we need to note down now, and we will write it as steps so that whenever you want to revise, you can revise it. So, the next step is resolve all forces along. We have talked about two directions here, but sometimes there is a third direction also, which comes sometimes. Now, one is tangential, the other one is radial. Now, again, use some brain, apply some brain. What would be the third direction? Remember, there are only three dimensions in space. One, for us right now, is tangential. The other one for us right now is centripetal or towards the center. What would be the third? Remember, there are only three dimensions of space. Sometimes we might be requiring this third dimension in some questions. Now, what would be those? What would be that third dimension? To help you out, I'll just draw a diagram to make you understand what could be that third dimension. Again, I want you to understand and give me the answer rather than me babbling out the answer, because I already know the answer. If I tell you the answer, that will help you. But if you can come up with your answer by thinking, you will never ever forget it. And that is the reason that I am giving you this chance that, okay, this circle is not good enough. I'll just take this out and I'll make a better circle. Okay, this circle will do. Okay, so now the hint is this one. Let us suppose this is my circular path. This is the body which is hanging somewhere here. Okay, we have talked about two direction, and I'll make those. Let us say that the body has a mass m. We have talked about two directions here. The first direction here is this tangential. Do we understand this? This is the tangential direction. I'm not talking about x and y axis. I'm talking about tangential and radial. So this is the tangential direction. It could be here. It could be here, depending on how it is moving. It might be moving like this. It might be moving like this. If it is moving like this becomes your positive x-axis. If it's moving like this becomes your positive x-axis. No matter what, this is the tangential direction. Then what is the radial direction, or what is the centripetal direction? This direction here is the centripetal or the radial direction. Do we understand this? Yes or no? You understand this? Now, if this body moves from here to here, let me make it by green. Now the body remains blue. Now, if the body moves here, m, remember, now I'm making this direction in green now. Now, what are my tangential and radial directions? Remember, they have changed. Since it is circular motion, to say this direction in terms of x and y will be very difficult, because x and y cannot keep on changing like this. But talking it in terms of radial and tangential is always simple, because we always know what is radial and we always know what is tangential. Right now, when it reaches this point, remember, I'm talking about one specific point. There are infinite number of points between this point and this point. You understand that, right? So we are talking about specific point. Now, when it reaches here, this is one direction. Which is this direction now? This is one direction. Which is this direction now?
Tangential.
Which one?
Tangential.
This is the tangential direction, T. And now I can resolve the force in this direction also. This becomes the radial direction, R. We understand this? So this axis, when I say it in terms of tangential and radial, it keeps on changing. And I don't have to always say now it is like this, now it is like this. Just say tangential and radial. Everyone who understands tangential and radial will be able to understand what you are talking about. Right now, the problem is not like this. The problem is resolve all the forces along three axes. Three axes or three directions. One is this, number one. Two is this, two. Where is the third?
Perpendicular. Sir.
Perpendicular to what? Well done. It is perpendicular. Perpendicular to what? See, you use your brain and your brain will start working. Don't use it, it does not work. Perpendicular to what? Perpendicular is correct. Perpendicular to what? Let your brain work. Perpendicular to what? I can give you the answer in a minute. I don't have to talk so much. I'm wasting a lot of energy when I'm talking. I can give you the answer in a second. And I want you to answer. Perpendicular to what? Think. Okay. Right now, this, you can see this diagram. Perpendicular to the body, Teja says, what body? If you're talking about a body, I mean, there can be infinite number of perpendicular directions, like this, like this, like this, like this. Which direction, Teja, you're talking about? To give me the answer in terms of circular motion. This body is performing a circular motion. Now look at these directions. Look at the green axis, or look at the black axis, or I can draw an orange. Orange will not look good. Black is done. This is done. I can also draw orange axis. The orange axis, if it comes here, the orange axis will look like this. This will be the tangential direction, and this would be the radial direction. Where is the third one? Where is the third one? How does the
About
third
center
one?
of mass, sir.
Center of mass? I don't know that term. I have not gone through that term. So if I don't know that term, I cannot explain something in that terms, right? I don't know what is center of mass. Okay, let us first write the two direction. Number one is along. Number one is along tangent, right? Let us first write what we know. Number one is along tangent. Number two is along radius or radial. I will call it radial. You can also call it normal. You can call it centripetal. You can call it anything that you feel like. The third one is the one that is giving me the problem. No, it's not giving me the problem. We all understand it has to be perpendicular. Perpendicular to what? Look at all these 6 axes that I've drawn. 2 axes in green, 2 axes in black, 2 axes in orange. It has to be perpendicular to all these axes or any infinite number of axes that I can draw on the circle. So it has to be perpendicular to all those infinite number of axes. What is the direction which is perpendicular to all those infinite number of axes? Which direction is perpendicular? And there is only one answer for that. And what is the direction? It has to be perpendicular to all the axes that I've drawn right now or any infinite number of axes that I can draw. That direction has to be perpendicular to all those axes, and there is only one direction which is perpendicular to all those axes. And what is the direction? It should be perpendicular to. It should be perpendicular to what? To the plane of circular path, and that was the term I was looking for. It must be perpendicular to the plane on which the circular motion is going to happen. So right now, if this circular motion is happening on this plane, the body is moving on a circular path like this. Let me just put it like this. Okay, let me just put it like this. If the body is moving on a circle like this, ting, 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 remember, circular motion is not a three-dimensional motion. Circular motion is a two-dimensional motion. So if the circular motion is happening on this path, like this, on the surface of my phone, what should be the third direction in which I have to make equation if required? That is only if required. This is the plane on which circular motion is happening. This is how circular motion is happening. It's a two-dimensional motion. Remember, it happens on a plane. So what is the third direction in which I might have to make equation? What will be the third direction? No one knows? No? Still, you've written it. It would be perpendicular to this, so it would be in this direction. The direction which is perpendicular to this plane. So it could be positive z-axis like this or negative z-axis like this, depending on how you are taking your z-axis. So the third direction would be the perpendicular direction in which the motion is taking place. Am I clear with this concept? Do we all understand this? Can I have some raised hand that we understand this? Everyone understands this, right? Okay. These are the first two steps that we draw and resolve the forces. What would be the third step? And it is simply logical. What would be my third step? What would be the third step? I have drawn the forces. I have resolved them. What do I do? Sit and relax. Okay, my job is done. I have drawn the free body diagram. I have resolved the forces. Now let me sit and relax. Question will solve on itself. Does it happen that way? No. No, 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 no. Even God has to do his own work, right? And Bhagwan Ram and Bhagwan Vishnu reincarnated as Lord Ram, he had to go and kill Ravana. Ravana did not kill himself. Okay, Ram has come, I'll kill myself. No, no, no. He had to go and do it himself. By his own hands, he killed him. Ravana did not die on himself. Someone, Ram, Bhagwan, had to go and kill him. What happens next? You just sit there. Okay, Bhagwan will come and do my job. What happens next? What is the next step? Again, this step does not come from heaven. It is simply logical. It is simply physics. We have written it so many times. A chapter known as Newton's laws of motion, which you must recollect at all point in your life until you become as old as me. And if you're into teaching profession, you cannot even forget it. That yes,
Make equations.
make equations, right? And how do I make equations? We just have to formulate the force equation. So make force equations. And how do I make this force equation? I have to make force equation in 3 directions, right? Along tangent, Ft will be equal to m into at. Do we understand this? Do we understand this? This Ft would be the net force along the tangential direction. There could be gravitational force in the tangential direction. For example, if I look here, let me use this bluing. If I look at this point, oh, it's become too. If I look at this point, there is one force acting along the tangential direction. What is that force which is acting along the tangential direction? When this body is moving on the circular path, there is one force which is acting along the tangential direction. What is that force? That force is your gravitational force, mg. This mg is acting downwards, and this downwards is the tangential direction. So this will give me the tangential acceleration. There is no force in the upward direction. There is only force in the downward direction. Let us not call downward direction. There is no force in the upward tangential direction, but there is force in the downward tangential direction, and that will give this body downwards tangential acceleration. Do we understand this? Can I understand this? Can I have some reason that we understand this? So this is how, as you can see, when this body moves and it is at different points, the tangential forces and the centripetal forces are continuously changing. They will keep on continuously changing. Sometimes gravitational force will become centripetal force. Sometimes gravitational force will become tangential force. If there is a point in between, and we'll come to that point, if there is a point in between point A and B, I hope everyone can see point A and B. A is the lowest point, B is the horizontal wala point. Between point A and B, at point A, gravitational force is downwards. Gravitational force is always downwards. At point A, it is also downwards. At point B, it is also downwards. But remember, here our axes are not downward and horizontal. Our axes are changing. Let us talk in terms of radial and tangential direction. At point A, gravitational force is completely along the radial direction. I marked it by pink. Look at the pink. At point A, gravitational force is downwards. At point B, it is also downwards. But now we are thinking in terms of radial and tangential. At point A, gravitational force is along radial direction. But at point B, it is completely along tangential direction. What will happen at some point in between? And that is the question that you must answer now. Let us see, I have a point C in between. which I have drawn by green. I have a point C here in between. How will gravitational force be? Number one, will it be completely radial? Number two, will it be completely tangential? Number three, one part of it will be radial and one part of it will be tangential. What is the correct answer? At point C or any point in between, there could be this point C, or there could be this point D here, or there could be this point E here, or there could be this point F here. Between points I'm talking. There are 4 points which you must always remember. One is the bottommost point, one is the topmost point, one is the horizontal point on this side, one is the horizontal point on that side. So these are the 4 points which are very easily recognizable. But there are infinite number of points in between these points. I'm talking about 4 specific points: point C, point D, point E, point F. Gravitational force, is it radial? Is it tangential? Or it has both radial and tangential components? Which is the correct answer? No one knows it? It's not rocket science, you can see it. It's not rocket science. It is the simplest form of physics.
Both radial and tangential.
Yes, it will have both radial and tangential components. So we'll have to resolve gravitational force in radial direction as well as in the tangential direction. Apart from gravitational force, there could be other forces as well, which has to be resolved. So first of all, let us resolve everything along the tangential component. Ft will be equal to m into at, where at becomes your tangential acceleration, and ft, my dear friends, ft becomes your net tangential force. Do we all understand this? Can I have some raised hand that we understand this? That is the first direction in which we have to make equation. What is the second direction? That second direction is the centripetal direction. Find out the net force in the centripetal direction. When I say centripetal direction, it should be towards the center. Towards the center. Towards the center. And the net force towards the center must be equal to m into AC. We know what is AC. AC can be written as m into, not m, Vt square by r, or it can be written as m omega square r. Do we all understand this? Yes or no? We all understand point number 1 and 2? Now, coming to point number 3. Now, point number 3 is the perpendicular direction. Point number 3 is the perpendicular direction. Now, with some common sense, you can tell me how will the equation along perpendicular direction look like? Again, you have to use your brains. Use your brains. I'll give you 2 minutes. What should the equation in the perpendicular direction look like? The diagram is right there on your screens. You can see it. Now tell me, if this was the question and you had to make an equation in the perpendicular direction, what would the equation look like? I will give you 2 minutes to think on this. If you have any doubts, ask. I hope all of you has thought about it. All of you have thought about it. Can anyone tell me what would the third equation, if you ever make it, and we'll be making it, don't worry. If you ever make the third equation, how will it look like? In all the cases, it will look the same. Tell me, how will it look like? Tell me, how will it look like? In the tangential direction, you will find Ft, that will be equal to m into at. In the radial direction, centripetal direction, you will write the net centripetal force is equal to m into AC, m into Vt square by R, or m into omega square R. What would the third equation look like? It is, remember, perpendicular to the path of the circular motion. Anyone in the online class can tell me how will the third equation look like? Siri, Satvika, Raju, Sai, Sainath, Kushi, Shashank, Janu, Teja, Charit. All the students in the offline class. Anyone? See, there is no right answer and there is no wrong answer. The problem is when you don't give any answer, and that is a big problem. That is a very big problem. That means you are not using your brains. If you don't use your brains, there is no way that you are going to clear IIT at all. There is no possibility of doing it. If you don't utilize your brain and don't put it to use, see, there is no right and no wrong. I always tell you, even your wrong answer will have a right question. So I have to ask the right question so that the wrong answer becomes the right answer. What would be the third equation, third direction wali equation look like? Think what you think.
M into A perpendicular acceleration.
Yes, yes, beta. What would it look like? F
Perpendicular is
perpendicular.
equal to
Okay, F perpendicular will be equal to M into A perpendicular. Is that
Yeah.
what you are saying?
yes, sir.
Okay. Tell me, is the motion happening in that perpendicular direction? Is there any motion happening in the perpendicular direction? Is there any motion happening in the perpendicular direction? The body is moving on a circular path here like this. The body is moving on a circular path like this. Is there any motion happening in the perpendicular direction? Is there any motion happening in the perpendicular direction? A body is moving on a circular path. See, it is not rocket science. This is completely logical, simple. A body is moving on a circular path like this. Does there any motion that happens in this direction? If you can't understand this, there is a serious problem in your understanding. There is no motion happening in the perpendicular direction. It's so difficult to understand. There is no motion happening in the perpendicular direction. I don't know where your brains are. Simple case of a body kept on a surface. The body only moves like this. There is no motion happening in the perpendicular direction. The body does not move like this. Dhak, 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 dhak. It does not hit the floor and go up, hit the floor and go up. No motion in the perpendicular direction. Similarly, when the body is moving on a circular track, circular path, the entire motion right now is happening on this plane, on the plane where I am writing all these zigzag things. The entire motion is happening on this plane. Is it so difficult for you to understand that the entire motion is happening on this plane? No, it is not difficult, because circular motion is a two-dimensional motion. It only happens on a plane. So if it is happening on this plane right now is my pad. The entire motion is happening on this pad. What happens in the perpendicular direction? Nothing happens in the perpendicular direction. The body does not move in the perpendicular direction. It's so difficult to understand. So difficult to understand. Yes, so difficult to understand that nothing happens in the perpendicular direction. Tell me, is it so difficult to understand? Oh, if it is so difficult to understand, probably you have taken the wrong stream. You should have never taken physics or science ever in your life. If it's so difficult for you to understand that there is nothing happening in the perpendicular direction, you have taken the wrong stream. So nothing happens in the perpendicular direction. The entire motion is confined to a plane. It happens in this direction. It happens in this plane. Nothing happens in this direction. And therefore, No motion in this direction. No motion in perpendicular direction. No motion in perpendicular direction, and hence net force will always be equal to 0, or instead of writing it as net force, I can write it as F perpendicular will be equal to 0. Whatever force is acting, if this is the perpendicular direction, if I take this plane, this is the perpendicular direction. Whatever forces are acting in this direction, same force must act in this direction. If the plane is like this, if circular motion is happening like this here, upward direction, whatever forces are acting, same force must act in the downward direction, because there is nothing happening in this direction. If the circular motion is happening like this in this plane, I hope everyone can understand this. If the circular motion is happening on this plane like this, whatever forces are acting in the positive x, same force must act in the negative x, because net force should be 0 in the perpendicular direction, because no motion happens there. Am I clear with this point? Can I have some raised hand that we understand this? Was it so difficult for you to understand that no motion is happening here? No, it should not be so difficult. If it is difficult, that means you have not understood the basic concept. So what I'll do is, I'll go back again and I'll try to make more sense out of it. So I'll just again go and repeat the steps. These are important because if you understand these steps, you understand the entire concept, and there is nothing more left to do. So now everyone will repeat with me. In fact, some of you would tell me what is the first step. The first step is right now. So some of you take the mic and tell me what is the first step and make me understand how you do the first step. Who is going to do that? Do it fast. I don't have the entire day. Some of you would tell me what is the first step. It's written right there. Read it and make me understand. Make everyone understand how to do it. Anyone in the online class would like to do it? Siri, Satvika, Yashwant, Raju, Sainath, Khushi, Shashank, Jagdish, Teja, Charita. Anyone in the offline class? What is the first step? Why is everyone so shy in speaking? If you are so shy in talking, you go to a medical college or you go to engineering college, you will have the worst time in your life. Worst time in your life. And you will feel that you are in bloody hell. You
Sir,
will be in hell. If you are so shy, you can't speak your mouth out, you will be in hell when you come to the engineering or medical classes, because you will be ragged so much that you will feel
Sir.
that you should get out of this medical college and live your life somewhere else. Yes.
Sir, draw FBD showing all force acting.
Okay. So at least the girls are smart enough to talk. Guys are useless, and they should be rotting themselves out in some pit. Okay, the first step is draw the free body diagram.
Drawing FBD showing all forces acting.
Great. What about the second step? What is the second step?
Resolve all forces along three axes.
What are the three axes that we are talking about here?
Along tangent, along radial, perpendicular to the plane of circular motion.
Okay, so one is along tangent, the other one is along radial or towards the center. The third one is the perpendicular direction. What is the next step?
Making forces equal.
Making forces
Force
equal.
equation, sir.
Okay,
force equation.
making force equation. How do I make the force equation? The first equation is along.
Force along tangential is equals to MAT.
Okay, the second equation is
Centripetal force is equals to MAC.
The third direction, if you ever have to make it, then
No motion in perpendicular direction.
therefore whatever
Is
force,
equals to 0.
whatever forces are acting in one direction, same force must act in the other direction, so that the net force becomes zero. But sometimes even solving up till these three steps will not be sufficient. Then we would need the fourth step. Now I know that you may not know that fourth step, so that fourth step I will write on my own. After making these equations, you will have a set of equations, but even those set of equations may not be able to solve the question. Then we come to the last step. And what is the last step? Last step is write the equation for work energy theorem. So you can use either the equation for work energy theorem, or if you don't want to use work energy theorem, if there is no friction, or use the equation of Lockme. Do you remember what is Lockme? Do you remember what is Lockme?
Yes, sir.
What is that, beta? What is that?
Law of conservation of mechanical energy.
Well done. Only girls are useful here. Guys are useless. Shame on them. So write the equation for work energy theorem or log में. So there would be some equations that you can make. Okay, Teja has woken up, at least in the online class. Welcome to the class, Teja. I hope more of you wake up. Anyways, I don't like guys first in the first case because they are useless. I don't like myself also because I am a guy. They are useless. They they're useless. They don't care for themselves. They don't care for their parents. They don't care for anything. They are useless. I am also useless. All the guys are useless. Only girls are the important part in the society. If girls are not there, society doesn't function. So I'm very proud of girls. Good one. I don't care about boys. They are useless. But Teja seems to be the one who works. So I put you in the girls category. I mean the category which is important. So write the equation for work energy theorem or Lockme. So we'll write that fourth equation. What is the fifth step? And in fifth step, nothing has to be done. No, everything has to be done in the fifth step, because right now we have just written the equations. These equations will have some unknowns. These equations will have some knowns as well. Something would be known to us, something would be unknown to us. And then we have to check what we need to check, whether the number of unknowns, let us for example, I say we have four unknowns. Let us say we have four unknowns. We must make sure that we have four equations, because four unknowns need four equations to solve. If there are four unknowns and three equations, that means you cannot solve it. It's as simple as that. So if, for example, in one question we have four unknowns, after these four steps we must have at least four equations. We need to check that. It is simple logic. We will not write it. So the number of unknowns and the number of equations must be same. Once we do that, once we find out that the number of unknowns and the number of equations are same, what do? We solve those equations. That is pure maths. Solve equations and get the values of unknown. This fifth step is completely a part of maths. So I will do nothing in this step. I will, the physics wala part finishes at step number 4. And that is the last step from now onwards that I'll do. I will not do the fifth step at all. So I'll not solve the problem. Once the equations are there, you will have to solve it, because that is part of mathematics. Simple equations, you can easily solve them. I might solve one or two of them, but after that you will have to take care of the entire equations. Do we understand this, everyone? Can I have some raised hand from boys and girls all together? Okay. So what I would tell you since today was such an important class, and boys have not participated in the class, and that is why I have given them a bit of shock treatment. I would request all of you to go through this class once again. If you have not understood anything in this class, please go through it once again, because from now onwards, whatever we do, this is the last time that we are doing all this. Force is going to finish, and these equations that we are doing right now will be coming everywhere from now onwards till the end of your curriculum course, and these are very important class. This is the probably the most important class for this year, and that is why I wanted all of you to be attentive and participate in the class, but boys have not done it. So you have time. I'll give you time. Today is Friday, Saturday, Sunday. The next class is on Monday. Go through this class once again. There's any doubt in your head regarding anything, we will clear it before the next class on Monday. I mean, on the next class in Monday, I'll take 10 minutes off and I'll go through all your doubts in this particular thing, because if you understand this, life becomes very simple. Even though we are doing this for circular motion, remember the same equations can be made for any motion. If I just give you an example, if I go back in time, and you see, it is very easier for me to go back in time because we are studying physics. See, let us go back to this. And I'm just going back. Oh, have I gone back too far? Have I gone back too far? Lecture number 2, lecture number 3. Yeah, if I go here to this lecture, see, if I go back to this question, this was a question that we did in the chapter on force, the first question. Remember this F minus F was not the net force. This F minus F was not the net force. This F minus F was the force in the horizontal direction. Now, instead of calling this direction as horizontal, I could have called this direction as tangential direction. In fact, tangential direction would have been the right term for this direction. This was my tangential direction. This was my tangential direction. Remember, this motion was happening on this plane. This was the plane on which the motion was happening. This was the plane on which motion was happening. This direction was tangential. One direction was radial, which I cannot show here on this plane. And the third direction was perpendicular. So if I draw this axis, this was the perpendicular axis. And the perpendicular axis, the net force was 0. So even this question was done with tangential, centripetal, and perpendicular direction. So if you understand today's class, it encompasses everything that we have learned so far in mechanics. Go through this class once again and let us come back on Monday and carry forward this class. Am I clear with all of you? Do we understand this? Can I have some raised hands at the last? We go through this class once again. Okay, and I would see more participation from all of you. Wave your hands and let me know that I'll see more participation. Okay, then I'll wind up this class and leave you here. If you've got any doubts, I'm here. I can solve them. I hope all of you have got vaccinated. All of you who have got vaccinated, please raise hands. I think you are eligible for vaccination, right? Only girls, no boys still. Boys are useless, always useless. Anyways, again, I would request, okay, 4 participants have raised hand in the, okay, Khushi has got, see, girl, Sainath has got, Shashank has got, well done, yeah, well done. So many of people have got vaccinated. Siri has got, Raju has got vaccinated, Jagdish, Teja. Online students are doing a lot better than the offline ones. You've not got vaccinated and you are in the class. That is a dangerous thing to do. Go back, get your registrations done, get vaccinated, beta. It's for your own good. That's the only way we can defeat this virus. We have to defeat this virus. We have to also defeat one exam that is going to come sometime next year, 2 or 3 months from now. So we have got 15 months in our hands, at least. I hope we can give the best shot in the 15 months. 15 months is a good enough time to complete everything that we have that is left, or everything that was not done correctly. 15 months is too good a time. I hope from today onwards everyone will wake up, and we will do more constructive studies in the next class. On that note, I'll wind up today's class. Anyone has any doubts, please come up. Else, enjoy your life. Take care.
Bye, sir.
Bye bye.
Thank you, sir.
Bye.